Right, so this is going to be the last class for remainder theorem. This will be the last class for remainder theorem. And in this class, we are going to learn about Euler's. We are going to learn about Euler's remainder theorem. Okay. And it is also known as the Totient theorem. So once you understand this theorem, please remember that whatever questions that you can solve using the binomial theorem, you can solve it using this Totient theorem. Whatever questions that you were able to solve using the Feynman's theorem and Wilson theorem, you can also solve it using the Totient theorem as well, okay? Or if you are confused on which theorem or which process to use exactly, leave everything aside and just use this theorem, because with this theorem, you would be able to solve most of the questions. So you can also do that. First, let's discuss on the concept of Euler's theorem. So according to the concept of Euler's theorem, for any number, okay, divided by the natural number, for any number divided by the natural number with the Totient function of that same number, the remainder will be 1. So I do understand that it will be difficult to understand what is the exact meaning of this one, isn't it? No issues, I'll give you a simpler explanation for it, but first remember that this one means Totient function. This one means Totient function of n, and n, as you know it, is a natural number. And the condition is that a n should be co-prime. This one is very important, okay? They have to be co-prime. This and this has to be co-prime, meaning the HCF has to be 1. Their HCF has to be 1. Other than that, you will not be able to use Totient theorem, okay? So you might be having the same question. What are we going to do if they are not, like co-prime? We'll get on that as well, but for now, let's learn about this one. So first, let's go ahead and learn what do you mean by Totient function. So what do you mean by Totient function, or what is the Totient function? What is the Totient function of let's say 10, or what is the Totient function of 10? You can also write it in this way, or you can give the symbolic representation, okay? So first, I'm just going to assume all of the numbers up to 10. And here I'm going to check 10. 10 is divisible by all these numbers, isn't it? Okay, 10 is having some common factors with all these numbers. So as you can see over here, 10 and 1, they will have the HCF as 1. 10 and 3 is having the HCF as 1. And 10 and 7 is having the HCF as 1. And 10 and 9 is having the HCF as 1, isn't it? Meaning my Totient function of 10 will be 1, 2, 3, 4. Okay. Or how will you say Totient function? Basically, what you mean by Totient function is that the numbers from 1 to 10 who are having the HCF as 1, or who are having the co-prime with 10. Okay, that is basically what you mean by Totient function. But let's say, what about if you are asked to find the Totient function of 200? How will you do that? It will be a little bit difficult, isn't it? For big numbers, you will not be able to write up to 200, and you will not be able to double check on which of them would be having the HCF with the same number as 1. So that will be really difficult, isn't it? So we do have another method for that, and over there we are going to use the prime. factorization method. We are going to use the prime factorization method for this one, and according to the prime factorization method, this is what it is. Okay, so first I'm just going to consider the prime factors of 10, which is 2 and 5. Totient function of 10 will be equal to, just write 10 over here, 10 into the prime factors are 2 and 5, isn't it? The prime factors of 10 are 2 and 5. So 1 minus 1 by 2 into 1 minus 5. So 1 by 5. So if you make the calculation for this one, you will be getting half into 5 minus 1 is 4. 4 minus 1 is, 5 into 1 is 5. 5 minus 1 is 4. 4 upon 5, 2. 5 are 10. So the totient function is 4. Okay. This is basically how you find the totient function. And how am I going to solve it using the totient function now? So if you're going to solve any equations that is coming with powers, all right, and if you're asked to find the remainder, and if you can see that both of these numbers, they are co-prime, you can use totient function. All right. We do understand that in order to use binomial theorem, the factors or the difference between this and this has to be 1. But as you can see over here, we are not having that condition, isn't it? So basically, we will not be able to use binomial theorem. So if I'm going to use Totient theorem, this is how I'm going to do it, okay? All right, so I'm going to solve all these questions one by one for better clarity over here. So if I'm going to find the totient function first, if you're going to use the totient theorem, first thing first, find the totient function of 49. The prime factors of 49 will be 7 into 7, meaning 7 square. So totient function of 49 will be equal to 49 into 1 minus 1 by 7, which will be 49 into 7. 1 is 7. 7 minus 1 is 6 by 7. 7 7 are 49. 7 6 are 42. Okay. So this is the totient function of 49. The totient function of 49 is 42. After this, how will I solve? Therefore, 13 to the power 127 upon 49. This is the totient function, isn't it? Whatever power that you are having over here, you have to divide with that totient function. Okay. So if you divide these two, what remains? 42 into, 127. 3 2 are 6, 3 4 are 12. So the remainder is 1 over here, isn't it? If you solve this 2, you are getting the remainder is 1. So 13 to the power 1 upon 49, which will be 13. So 13 is smaller as well. So my remainder will be 13. That's it. Okay, this is how you solve them. So this is basically how I am going to find the remainder using Totient theorem. And let's go ahead with the next question as well. First, what are the prime factors of 18? For 18, we are having 2 9 are 18, 3 3 are 9. So 2 into 3 square, isn't it? The totient function of 18 will be equal to 18 into 1 minus 1 by 2, which is this one, into 1 minus 1 by 3, this one. So this will be 18 into 1 by 2 into 3 minus 1 is 3 into 1 is 3, minus 1 is 2 upon 3. 2 3 are 6, 6 3 are 18, 3 2 are 6. So the totient function is 6. Okay. So now I'm going to make the calculation for this one. 5 to the power 75 upon 18. I'm going to divide this one with the totient function. 75. If you're going to divide it by 6, 1 is 6, 15. 6 2 are 12. The remainder is 3. So the remainder over here is 3. So what will you get? 5 to the power 3 upon 18. Okay. So we know that 5 to the power 3 is 125 upon 18. So if we divide 125 with 18, what will be the remainder? Okay, 18 into how much? 18, 125, 7, 8 are 56, 5 in hand, 7, 1 is 7, 8, 9, 10, 11, 12. So 126. I'll be getting the what? I'll be getting the negative remainder is 1, isn't it? Negative remainder is 1, meaning my actual remainder will be 17. Okay. Now if I'm going to solve the next questions over here, as I've mentioned earlier, first thing first, you always have to find the Totient function of the denominator or the natural number. Okay. So how will I do that? First, I'm going to find the Totient function of 35. Totient function of 35 will be 35 is 5 into 7 is 35. So see, in your examination, you will not have the time to write 1 minus 1 by 5, isn't it? So simply do it this way. 5 minus 1 is what? 4. 7, write 7. 7 minus 1 is 6. Do it that way, okay? So this is gone. 4, 6 are 24. So over here, I'm going to write 19 to the power 97 upon 24 divided by 35, which will give me 24 into 95, 4, 4, 16, 4, 8. My remainder is 1. So 19, 35. 19 is smaller, so remainder will be 19. That's it. What about 40? 10, 4 are 40, 8, 5 are 40. 2 cube into 5, isn't it? So my Totient function of 40 will be equal to 40 into 2 upon 5. 5 minus 1 is 4, 2 minus 1 is 1. 2, 5 are 10, 4, 4 are 16. All right. So we are getting the Totient function of 40 as 16. So therefore, 11 to the power 130 upon 16 by 40 will be equal to, as you can see over here, 16 upon 130 will be how much? So 6 6 are 36, 6 1 is 6, 9, not possible. 8 6 are 48, 8 1 is 8, 9 10 11 12, almost. Hmm, 9. No, it's not possible. It has to be 8. So 8 6 are 48, 4 in hand, 8 1 is 8, 12. I'm getting 2. So over here, my remainder will be 2. So it will be 11 square upon 40. 11 square is 121 upon 40. So if you divide 121 with 40, it will be 3, 4 are 12. So the remainder will be 1. Okay. So we are having 3 more questions over here. Okay. I'm going to solve this one. You can use this one for practice. Okay. Hold on. I believe let's solve it that way. This will be 5, isn't it? So the Totient function of 25 will be equal to how much? Totient function of 25 will be equal to 5 into 4 by 5. 5 5 are 25, 5 4 are 20, isn't it? So directly I can also divide this one with that one with the power directly. So just divide directly over here. What will you get? Therefore 37 25. How much will be the remainder? 7 2 are 14. So remainder will be 2. So I can write 37 into 37. Instead of writing 37 square, I can write 37 into 37 upon 25. Reason being that remainder will be 12 over here, isn't it? 12 into 12 is 144 upon 25. right? So for 25, if I'm going to compare this one, the remainder will be 19. Okay. Totient function of 90, how much will be 90? 90 will be 3 into 2 into 5, 3 square. 2, 5 are 10, 3 square is 9, 90. So it will be 90 into 1 by 2 into 2 by 3 into 4 by 5. So 2, 5 are 10, 0 cancel each other, 3, 3 are 9. So 3, 2 are 6, 6, 4 are 24. 97, if I'm going to divide it 24, 4, 4 are 16, 4, 2 are 8, 9. So the remainder will be 53 to the power 1 upon 90. So my remainder will be 53. Okay. 400, totient function of 100 is 40. Better learn this one. Okay. It's a very common one. So 117, if I'm going to divide this one with 40 over here, I do have 200, 5 4 are 20. So it will be 2 upon 100. So instead of this one, I can write 117 into 117 upon 100. It will give me my remainder as 17. 17. Okay. The last two digits is 17, isn't it? 17 into 17 is 289 upon 100. So remainder will be 89. That's it. And over here, you can also solve it in the same manner. First, please understand that the sign is plus over here and the sign is plus over here. So this one, you can also write it as 23 to the power 722 upon 25 plus 24 to the power 722 upon 25. Or do understand that you can just use this one common for this one and common for that one. Okay. So if I'm going to solve this one in that manner, I can see over here that 25 and 24, the difference is just 1. So I can use binomial theorem over here. But that is not the situation over here, isn't it? So what I'm going to do over here is that first, where I'm going to find the totient of 25. If I'm going to find the totient of 25, it will be 5 into 4 by 5. So totient function of 25 will be 4. Divide 72 with 4, how much will you get? 4 1 is 4, 32, 4 8 are 32, remainder will be 2. So therefore, 23, if I'm dividing this one with the totient as 4, I'm getting the power as 2 plus, as you can see over here, 25 and 24, it will be minus 1, isn't it? Minus 1 to the power even number is always plus upon 25. So how much will it be? You can also see here that if you're going to divide 25 with this one, you're going to get the negative remainder as 2, isn't it? So minus 2 to the power 2 will be how much? 4. 4 plus 1 upon 25, it will be 5 upon 25. 5 is smaller, so remainder will be 5. And for these questions, I can see over here that 36 and this will give me 1 as my remainder. Minus 1 is my remainder. Minus 1 to the power odd number will be minus 1. 1, 0. So my remainder is 0. Okay. So up to here. Okay. Up to here, make proper revisions. Or should I say do proper revisions? Solve it like 3 or 4 times. Take rest for 5 to 10 minutes. Only then go ahead and try this type of questions. Okay. This is like the advanced level for totient function. We are going to follow the same exact process, but a little bit differently. All right. So what I'm going to do over here right now is that first, if I'm going to divide this and this, I'm getting the remainder is 4, isn't it? Am I right? So I'm going to write this one as 4 to the power 32 to the power 32 upon 7. Okay. Now I'm going to solve the powers over here. So what will you do? How will I do? I'm just going to write down this one as 32 to the power 32 divided by the totient function of 7. See, Totient function of 7. 7 is a prime number, isn't it? Whenever you are going to find the totient function of 7, it will become 6 by 7, cancel out each other, 6. So as long as you are getting the finding the totient function of prime numbers, this is only for prime numbers. For prime numbers, simply subtract it by 1 and you will get the totient function. So I do understand that the totient function of 7 is 6. So I'm going to divide all this with 6. All right. So if I'm going to divide all this with 6, what will be the remainder this time? The remainder will be 2, isn't it? So 2 to the power 32 upon 6. This one I can modify it as 2 square upon 2, 1 is 2, 2, 6 are 12 upon 6, which will be 4 to the power upon 6. Yesterday we have done the question stating that 4 to the power anything upon 6 will always give me my remainder as 4, isn't it? This is the remainder. Please remember that we are using the remainder. We are using the remainder for the powers, isn't it? So what will I write over here now? So I'm going to write 4 to the power 7. What is the remainder? The remainder is 4. Okay. So this one I can also write it as 4 4 are 16 into 4 4 are 16 upon 7. 7 2 are 14. So remainder will be 2. Remainder will be 2. So it will be 4 upon 7. So my remainder, it will be 4. Simple as that. Okay. I'll tell you what is the confusing part. This is the confusing part, but we are using the same logic, all right? Just for the powers, find the remainder. The remainder will become the new power. That's it. Okay. Now if I'm going to solve this one, 9 and 25, how much will be the remainder? 9 3 are 27. For now, I will not be able to take negative remainder, so 9 2 are 18. I'm supposed to take 18, so remainder will be 7, isn't it? So I can write down this one as 7 to the power 25 into 25 upon 9. Going to solve all these questions separately. 25, 25, 9. Totient function of 9 will be how much? Totient function of 9, it will be 8 by 9. 9 and 9 cancel each other. So the totient function of 9 will be 8. Okay. Now you can see over here that 8 3 are 24. So I can use binomial theorem. Remainder will be 1. 1 to the power 25 is 1 upon 8. So my remainder is 1. Meaning that in place of all this, I'll be writing 1. 7 to the power 1 upon 9. Remainder will be 7. That's it. Okay, we are going to solve all this as well. 113 upon 97 upon 96 upon 97. Okay. 8 2 are 16. My remainder is 1, isn't it? I can also use binomial theorem. See, this is the even number and this is the odd number. If you multiply even number with odd number, you will get even number. So minus 1 to the power even number is what? Plus. Remainder is 1. Simple as that. You don't have to use Totient theorem. But for this one, 16 2 or 32. So my remainder will be 3. So for the next step, I'll have to write 16 upon 3 upon 33, 31. I'm going to deal with the powers differently. So 33 upon 31. What is the totient function of 16? The totient of 16 will be equal to 16 into 4 4 are 16, so 1 by 2 it will be 8. Totient function of 16 is 8. I know that 8 4 are 32, so power will be negative, remainder will be 1. 1 to the power 131, so this is my remainder, meaning that I have to write 1 over here, meaning that 3 will be my remainder. Okay, it's rather easy, isn't it, once you get a hang of it. And after this, for the last questions, 97 is a prime number, so the totient function of 97 will be how much? 96. That's it. And 97, if you divide 97 with 113, how much will be the remainder? 16. My remainder will be 16. So I'm just going to write down this one as 16. 97, 96 upon 97. And if I'm going to solve all these questions separately, 97 upon 96 divided by the totient function, which is 96. 96. The difference between this and this is 1, so I can use binomial theorem. My remainder will be 1. So 16 to the power 1 upon 97, my remainder will be 16. That's it. Okay. We have solved this type of questions using what is that? The last digit method as well, but that one is for last digit method, and this one it's remainder theorem. The focus over here is the remainder, not the last digit. Okay. All right. So you do get this type of questions in our ecstasy examination, so we are going to solve this one. And okay, hold on. Yeah, I think that's better. Hmm. So for this type of questions, I'm just going to focus on this part for the time being. Okay. Just take out this part with 7. So what will you get? 10 to the power 10 upon 1 upon 7. So as you can see over here, it will be the remainder will be 3, isn't it? So 3 to the power 10 upon 1 upon 7. You can also solve it using this manner, isn't it? But if it gets confusing for you, you do have another process, so no worries on that. However, for now, let's discuss about this one. So what will I get? 10 to the power 1 upon 7 is a prime number. So the totient function of 7 will be 6, isn't it? Upon 6. How much will I get now? The remainder will be how much? The remainder will be 4, isn't it? 4 upon 6. So my remainder will be 4. So as you can see over here that between this and this, you are getting the remainder as 4, meaning that, let me put it that way. Between this and this, you are getting the remainder as 4, meaning between this and this, you will get another 4. Another 4. How many 4 will you get? You will get up to 34, isn't it? So all of them are plus as well. So instead of writing 2 plus 2 plus 2, you can write 2 into 1, 2, 3, isn't it? In the same manner, I'm just going to write 4, which is the remainder. Okay, 4, which is the remainder already. Or you can also do it this way. Therefore, 10 to the power 4, 10 to the power 4 upon 7 into how many times? 30 times, isn't it? So 30 times will be how much? 10 to the power 4 upon 7. How much remainder are we getting over here? For this, we are getting the remainder is how much? 7 4 are 28. So this one, the remainder will be 2. So 2 into 10 to the power 4. We are getting the remainder as 4, isn't it? Upon 7. So 2 4 are 8 upon 7. So remainder will be 1. That's it. Okay. Now you can see over here that these are having double powers. But as you can see over here, it's a single power, isn't it? So 10 to the power 1 upon 6. How much will be this? 10 to the power 1 upon 6. My remainder will be 4, isn't it? 6 1 is 6, remainder is 4. Am I right? So what will you do? Using this, I'm going to get the remainder as 4. How many times? just consider the power 1, 2, 3, 4 up to 100, meaning this one you will be getting 100 times with 6. So the remainder for this one will be as well 4. So 4 into 4 is 16 upon 6. So my remainder will be 6 2 or 12. 2. 6 2 or 12, 13, 14, 4. So 4 will be my remainder. Okay. This one, it's really advanced questions. And you will be seeing this type of questions maybe for math or CAT or CDS examinations. But for SSC examination, if you cannot understand this question, you are allowed to leave it out. Okay. As I said, we want to give you the ideas over here. That is the reason why we are including the questions. So as you can see, the power over here, they are the same. So I'm just going to use the shortcut process. Using these two, if I add them up, I'll be getting 90 to the power 93. In short, I'll be getting 93, right? And over here, you are having 88. So with 2 and 88, you'll be getting another 90. 3 and 87, you'll be getting another 90. You will be getting lots and lots of 90, isn't it? So what will you do? I'm getting 90, okay, to the power 93. Plus, you'll be getting like this in this way until in the middle, you are having 45. So plus 45 to the power 93. That's it. And this one, it will be divided by 90. So 90 and 90, you'll be getting 0. So this is gone. 45 to the power 93 upon 90. How much will be the remainder over here? I can simply note down this one as 45 into 45 to the power 92 upon 90, isn't it? And now I can divide this one. 45 into 2 is 90. I'm dividing it by 2. Remember that one, okay? Whenever we divide it by 2 using the finding the remainder theorem, finding the remainder using remainder theorem, we usually later on multiply the remainder with this number, isn't it? So note that number for now. So if I'm going to find the remainder using 2, what will I get? No, we are dividing with 45, not 2. So 44, we are going to get the remainder as 1, isn't it? 1 to the power 92 will be 1. So 1 by 2, meaning the remainder is 1, meaning the actual remainder. The actual remainder will be equal to 1 into 45, which is 45. Alright. And for the next questions, it's rather simple, okay? This one, I'll be getting the negative remainder as 1. 9 8 are 72, 8 9 are 72, so I'll be getting 5 as the remainder over here. 7 7 7, 72, 57, 56. My remainder will be 1 over here. 7 7 7, 72, 56, 17, 16, 1. Remainder will be 1, it will be 1, it will be 1 until the 100 terms, it will be 1. So what can you say from this one? Minus 1 plus 5 plus 1. If you are having 100 terms and if the first two terms are giving this one, meaning you are left with 98 terms, isn't it? So 8. 5 minus 1 is how much? 4. 98 into 1 is how much? 98 upon 8. 98 upon 8. Remainder is 2 over here, isn't it? So 4 plus 2 is how much? 6 upon 8. So my remainder is what? 6. Simple. So in these questions, they're asking us to find the last digit. All right. So if I'm going to find the last two digits over here, okay, what will I do? Moment. Okay, so if you're going to find the last two digits, I have informed you earlier that in order to find the last two digits, you have to divide it by 100. If it is like the last three digit, it has to be divided by 1000, isn't it? So divided by 100, 43 to the power 362 upon 100. How much do we get over here? Totient function of 100 will be how much? 40, isn't it? So 362 divided by 40, 900,936. Remainder is 2. So 42, 432, 43 square upon 100. All right. So how much exactly is 43 square? 1849 upon 100. What is the last two digit? 49. The remainder is 49. Or the last two digit is also what? 49. That's it. You must be wondering, when we're trying to find the last two digit, why do we have to divide it by 100? See, if you're dividing this one by 100, what do you get? 1, 100, 84, 8, 800. What do you get? Isn't it? That's it. 37, last three digit. So I have to divide this one using what? Last three digit means 1000. If the totient of 100 is 40, 1000 will be 400. That's it. Okay. So if I'm going to divide 2000 with 400, 5 will give me 20, remainder is 2. So I'm going to get 87 square over here upon 1000. And how much is 87 square? 87 square is 7569. So upon 1000, the last three digit 569. That's it. And for the next type of questions, these are some of the questions wherein this number and this number, they are not co-prime. If they are not co-prime, you cannot use binomial theorem, you cannot use Totient theorem, you cannot use Feynman theorem, and you cannot use any concept of the remainder theorem. For you to be able to use all those theorems, the numbers has to be co-prime. So what do I do now? If they're not co-prime, simple, make them co-prime. That's it, okay? Simple as that. If they are not co-prime, just make them as co-prime. How will I make them co-prime? This one I can write it as 2 into 2 to the power 99 upon 100, isn't it? So if I cancel this 2, how much will I get? 50. 50 and 2 are the co-prime. Oh, it's 102. Okay. Now you can see that 2 and 51, they are co-prime, isn't it? Meaning you can use Totient theorem, okay? But please remember that you are dividing using 2, meaning you have to multiply the remainder again with 2, okay? So the Totient function of 51, 51, 31 is 3, 3, 7 are 21, so 51 into 2 by 3 into 16 by 17, this is already 21, 32. Totient function of 51 will be equal to 32, isn't it? So meaning that I have to divide this one with 32. So 99 divided by 32 will be how much? 3 2 are 6, 3 3 are 9, meaning my remainder will be 3. So I'll be getting 2 to the power 3 upon 51. 2 to the power 3 is 8 upon 51, meaning my remainder will be 8. However, the actual remainder will be what? 8 into 2, which is 16. Rather simple, isn't it? For the next part of this question, same manner over here, 2 and 6, they are not co-prime. So what will you do? 2 into 2 to the power, if you are taking 2 out over here, it will be 2 to the power 83 instead of 84. So 2 to the power 83 upon 6. 2, 3, or 6, I'm dividing them with 2. Remember that one, okay? So totient function of 3 will be how much? 3 is a prime number, so totient function will be 2. If you're going to divide this one with 2, the remainder will be 1. So remainder is 2. Therefore, actual remainder will be 2 into 2, which is 4. Okay. And about this one, I can also write this as 20 into 20 to the power 107 upon 35. If I'm going to divide it with 5, 5, 4, 20, 5, 7, 35. So quotient function of 7 is 6. So 4 into, I just have to divide 107 with 6. 6, 1 is 6, 47. 47, 6, 8 are 48, no. 6, 7 are 42, 5. So 20 to the power 5 upon 7. Okay. So if you're going to solve this one, what will you get? 7 with this, the remainder will be 4. 7 with this, the remainder will be negative 1. You can use binomial theorem, isn't it? Minus 1 to the power 5 will be minus. So it will be minus 4, meaning it will be 3. Therefore, the actual remainder will be 3 into 5, which is what? 15. Okay. You can also go ahead and solve all these questions. For these questions, you'll be getting the answer as 9. For these questions, you'll be getting the answer as 24. And for these questions, you'll be getting the answer as 144. All right. We'll proceed ahead with the next concept, which is really important. Once in a while, it will come in your examination, but that's it, okay? This type of questions, they are not that common. So forget the questions for now. I'm just going to teach you the concept over here. So the first concept would be for the expression an plus b to the power n. Okay. If n is even, please remember that a plus b and a minus b, or how should I say, a plus b into a minus b is not a factor. Alright. However, if n is odd, a plus b is a factor. Just note down the expression for now, and when we are solving the equations, you will be able to understand them better. If n is even, a plus b into a minus b is a factor. Okay. And if n is odd, a minus b is a factor. Alright, I just have to copy down all this one, and using this as a reference, I'm going to solve it. So according to the questions which we are having over here, according to the questions, one of the factors, this and this, where k is odd number. You can see over here that the powers are the same, but in the questions we are having the powers, they are not the same, isn't it? So what will I do? Simple, okay? 8 to the power 2k plus 5 to the power 2k will be equal to 8 square is 64. 5 square is 25. The power is exactly the same now, isn't it? And question is saying k is an odd number. A to the power b n plus b. The sign over here is plus, and when it's odd number, a plus b is a factor. So therefore, they're asking us to find the factors as well, isn't it? So what will be the factor? 64 plus 25 will be a factor, meaning 89 will be a factor. This will be my answer. That's it. Okay. For the next questions, we are having the powers are the same exactly. and the power is odd number, and it is plus over here. So what do we get? If it is plus over here and this is odd, we are having a plus b is a factor, isn't it? So a plus b will be 127 plus 97 will be how much? 422. Okay, and they're asking us to find the remainder. All right, so 224 upon 32. 32 can divide this number exactly, so remainder will be 0. The remainder when the powers are exactly the same and it is odd number. So when the powers are exactly the same and it is odd number and the sign being negative, what do we get? We are having that a minus b is a factor, isn't it? So what will be a? 756 minus 412. This one will be 443. And I just have to divide 344 with 86. So I can divide these two numbers. So my remainder will be 0. 41. What is the remainder? This is divisible by the powers is exactly the same and they are even power and the sign is negative. So when they are even power and the sign is negative, we are having a plus b, a minus b as the factor, isn't it? So a plus b will be how much? 234 plus 123. A minus will be 234 minus 123. So this one will give me 753 into 111. So how much will this one be exactly? Oh, I'm just going to find the divisibility of 19 as well, isn't it? That means you don't have to actually find the product between these two numbers. 119. I'm going to get negative remainder of minus 8 over here. But this is divisible. 0 into anything is 0, so remainder is 0. And you can also write this 15 over here, isn't it? So 15 is odd. The sign is negative, so a minus b is a factor. 49 minus 1 is a factor, 48. 48 is exactly divisible by 8. That's it. So the powers, again, they are not the same, isn't it? What do we do when the powers are not the same? Make them equal. 2 to the power 6n minus 4 to the power 2n. 2 to the power 6 is 64. 64n minus 4 square is 16n. The power n, they mention n is a natural number, so we have to take both these scenarios, okay? So if I'm going to consider both these scenarios, n is equal to even, n is equal to odd. When n is equal to odd, a minus b is a factor, meaning 64 minus 16 will be a factor, meaning 1848. When n is even, a plus b, a minus b is a factor, meaning if I sum them up, 10, 80 into 48. So as you can see over here that both this number and this number will be divisible by 48 alone. So that will be my answer. Okay. 2 to the power 16 minus 1. I can also write 2 to the power 16 over here, isn't it? This is divisible by. No, it's the power is even number, meaning a plus b. A minus b is a factor. So 2 plus 1 is 3. 2 minus 1 is 1. Hold on. 2 plus 1 is 3. 2 minus 1 is 1. The powers, they are too small, isn't it? We cannot identify using the answers over here. So I can also write this one as 2 to the power 4 4 minus 1 to the power 4, 4. So this one we can write it as 16 to the power 4 minus 1 to the power 4. Okay, we are having big numbers now. So therefore, a plus b, a minus b is a factor, means 17 into 15 will be a factor, and this one will be divisible by exactly 17. That's it. Okay, so this is the end of your remainder theorem. Tomorrow we will be doing fraction-based series, and that will be the composition of your number system. All right, thank you.